Right, updating of biosafety testing. Let's have a look at the biosafety solutions in a changing landscape with typical relevant to CHO-based biologics. Okay. For the biosafety aspects, we're basically talking about adventitious agents, adventitious viruses, things that shouldn't be in there, from raw materials, from cell banks, from any of the components that we use in the manufacturing stages. And largely the focus has been historically on classical in vitro adventitious viruses to detect the wide plethora of viruses found in raw materials. That includes cell banks, serum from bovine, caprine, porcine origins, etc. Wide variety of viruses. And there's also been a historic focus on in vivo assays. And you can see there I've got the MAP and the HAP. That stands for mouse antibody production test and hamster antibody production test. Both of these are relevant tests to detect the presence of viruses. They're injected into the rodents, and then you look for replication of viruses by production of antibody. Okay, complicated, messy tests. They're in vivo tests as well. And then we have compendial assays. You'll all be familiar with the sterility in the mycoplasma assays, okay? That forms the basis, along with identity and various other things, that forms the basis of the biosafety testing up to date. But we do have a very important development, which is an ICH Q58 update, which provides a very much revised position on the acceptability of rapid methods. Now, there's been a lot of gnashing of teeth and consultation and discussions between manufacturers, testing labs and regulatory agencies on what the best way to go forward is. Of course, with patient safety at the top of everybody's thinking, including ours as a testing lab as well. But the update in ICH Q58 does enable manufacturers to explore alternative testing packages, okay, and position rapid CMC processes to maintain that patient safety, but with shorter turnaround times and a shorter amount of time from raw materials to revenue for a particular product. All of this means that new rapid technologies are very relevant to us, and you've heard some of my colleagues from the Utrecht site talking about next generation sequencing. And it also means that nucleic acid tests for impurities and contaminants, such as mycoplasma, are very much the order of the day now, very much expected, accepted, and used by manufacturers. If we look across the biosafety aspects in ATMPs, you've got your typical, as I like to think of it, a value chain or a CMC chain or a chain of safety or a chain of intervention or a chain of however you want to look at it. All of these things need to be done at all of those stages, okay? You've got research, cell line characterization, where you need genetic characterization as discussed earlier by my friends from Utrecht. And then to make the best clonal selection to reduce your risk of taking the wrong clone forward, you've got ID, mycoplasma, and sterility. And then at the cell substrate testing of master cell bank, working cell bank, and end of production cells, or cells at limit, depending on your terminology, you've got your classic mycoplasma, your sterility, 28-day in vitro assays. And we encourage 28-day in vitro assays at that point because they provide the greatest coverage against adventitious agents. Some of those viruses may be very slow growing, so 28 days is the most vigilant assay, okay, 28 days. And then we have human, rodent, bovine, porcine viruses, which does influence the collection of detector cell lines that you use in those assays. And then we've got here the in vivo assays, the MAP, HAP, PCRs for viruses that are not classically detectable by in vitro, hepatitis alphabet, for instance, hepatitis B, hepatitis C, hepatitis D, unlikely, hepatitis E, not very detectable, HIV 1, 2, HTLV 1, 2, parvo, B19, human cytomegalovirus, detectable, Epstein-Barr virus, not detectable. And then we have NGS virus testing and genetic stability, all relevant in biosafety to the master, working, and end of production or cells at limit stage here. And then we have a focus on the unprocessed bulk harvest. Typically in biologics, you'd want to use a 14-day in vitro assay. Okay, and we'll talk about the difference that time makes. And then there's mycoplasma sterility in some shape or form, maybe biological activity, but next generation sequencing and PCR assays for any particular viruses. The most common virus encountered at this stage is the minute virus of mice, or the minute mouse virus. It's the same virus, a very small parvovirus. It's a known contaminant of rodents, and about 5 to 6% of the mice and rats that you find in the environment will be contaminated by this virus and be actively shedding it. So if you consider that things like plant peptones, which are often used in the preparation of media for cell culture, plant peptones are taken from large fields full of grass. Those fields have got mice in them. Mice, they do what they do in the grass. It all gets harvested, and each little mouse poop, for a mouse under its peak of viremia, it can have about 10 to the 6 viruses in it. Okay, so you need very little in a 2,000 litre bioreactor in order to run through and contaminate and infect and cause a catastrophic failure in a 2,000 litre bioreactor. Okay, so vigilance there is very important. And then we've got the PCR assays, again, retroviral particle counting, not for every batch, but still very relevant. But let's have a look at how this can actually help us. For pre-selection in raw materials, the research cell line is very important. And that full genetic characterization mitigates a very important risk. As friends from Syngenta told us earlier, if you don't have time to do it in the first place, it's very difficult to find time to do it again. And a master cell bank, from gene to master cell bank to CNC release, can take many, many months and cost you several hundreds of thousands of dollars. Okay. Now, money can be replaceable. I can't believe I just said that. Money can be replaceable. Try not to look at our chairman of the board when I say that. But time is far more difficult to replace. Okay, so making the best choice at that time of your candidate to go forward is a very important thing for you to do, especially when you've got a cadence of operation which is pre-booked for 2 or 3 years in advance. There's very little room to maneuver there. Now, moving to the cell substrate testing, this is where we can make a difference with updating. And if you can see here, the NGS viral safety would replace those classical in vivo assays, the MAP and the HAP. Now, I've been working in this testing area in adventitious agents and viruses for probably 12, 13, 14 years now. And all the times I've seen and heard about MAP and HAP testing being done, I've never heard or seen a positive. Okay, never heard or seen a positive, but they are there historically because the regulators put it in the regulations, so it has been done. ICH Q58 addresses that, okay? Not only from the point of refine, reduction and replace of the use of animals, but also because the next generation safety, viral safety, has developed to the point where it offers you a very comprehensive range and sensitivity in detection. So that offers you a chance to remove a troublesome part of the CMC package for cell line testing and replace it with a very tractable technology that takes a lot less time. And of course, you've also got the PCR assays as well there that we mentioned. Now, to go to unprocessed bulk harvest, we take a quick look through this again and remind ourselves. With a 14-day in vitro assay, a compendial mycoplasma, a compendial sterility, biological activity, NGS viral safety, etc. There's things we can improve there. The classic release for an unprocessed bulk harvest in the CHO would probably take several weeks, around about 6 to 7 weeks. Okay. If we take a look forward, we look here 5 to 6 weeks, and on the bottom left-hand side, we've got your EP sterility, compendial sterility. There's many days there, okay? The rate limiting step in that bottom left-hand corner is actually the EP sterility. The in vitro virus, adventitious virus test at 14 days is usually a few days after that for reporting, so that can take 17, 18, 19 days. That's not the rate limiting test there. MVM PCR standard turnaround in our lab is 7 days. The same for the mycoplasma PCR here. And you see what I've done on the bottom left-hand side is actually change out that EP mycoplasma because that's a long test. That's several weeks, okay? So already we're at 5 weeks, which is still a long period of time. If we consider what we can do here to update that, we take out the EP sterility, which is several weeks, and replace that with rapid sterility, maybe 7 to 10 days. You then have the in vitro adventitious virus, and if you're using 14 days, that means time for reporting afterwards means your batch release is typically 3 weeks or so, okay? And we've got an MVM PCR, a mycoplasma PCR, 7-day standard turnaround time. If we then go to the holy grail of getting a CHO release done in 7 days, we need to think very carefully about that last rate limiting step, which is the 14-day in vitro adventitious virus test. That means that we have a great opportunity to play here with the next generation sequencing adventitious virus assay, which we are currently developing in Utrecht right now. Arno's nodding. Aren't we, Arno? Yes. So we are, clear statement, we are developing an in vitro, I know I did the business case for it a couple of days ago. We've got an in vitro adventitious virus NGS assay, which is going to be coming to market in the back end of 2024 and be ready for 2025 in our other sites as well. So that will enable us to have a good shot at a 7-day turnaround time, which reflects not only the fact we're using the, should we say, widened goalposts that the ICHQ5A gives us, it also means that there are very significant advantages for manufacturers as well. It's not just a different way of baking bread, it's actually providing a very serious advantage to the manufacturers. It gives enhanced information for clone selection if we use that next generation sequencing at the front end, and it means we reduce risk of remanufacture. Removal of animal testing is an ethical improvement in itself. But here's where the manufacturers start to get very interested. We have a reduced turnaround time for lot release into downstream processes. Okay? It's a very important reduction in the time. And it also means that if we've reduced any complexities here, we can have a common approach to the release of biologics through this process by using a common strategy in the CMC. This means that we've got a shorter time to revenue of drug batch. Okay, now part of the post-licensing undertaking that a company will have is to make batches of drug available so that there's a period of inventory. Okay, so it's not just a question of your drug is clinically validated, you also have a responsibility to make sure that it's available. And if you suffer a manufacturing interruption, for instance, there's sufficient inventory to bring this to market and make sure that the patients have their drug uninterrupted. Now, if you have a far shorter turnaround time for the release and processing of this by taking the CMC aspect here away from 6-7 weeks down to 7 days, over time you're offering a significant benefit to your inventory management, but you're also reducing that time from raw materials to retail revenue, which for a batch of drug can be several hundreds of millions. Okay, significant improvement. And so where are we going with this? Well, we're talking about biosafety today at Solvias because we're bringing a biosafety capability to the market. That includes in vitro virology at 14 days and 28 days for classic CHO-based biologics. We are also bringing analytics on the in vitro level and a molecular biology level that will be able to support ATMPs, which include adeno-associated viral vector testing at the quantitative level and also for impurities, including adventitious viruses. And we'll also be able to offer that for lentiviral vectors as well. So you can see our sites here at Utrecht, where the Center of Excellence in Next Generation Sequencing will be. We've got biological capabilities here in Kaiserast, including molecular biology, and Hamburg, France, where I'm currently situated. We've actually opened an in vitro virology capability to GMP last year in December, and we are in the process of assay validation now for 14-day and 28-day in vitro virology. We're also going to be opening up a site on the East Coast. I'm not sure how much I can say of that, but that will also be a major site where we'll be able to support biologics and ATMP analytics. So I think that's what I wanted to share with you.